Bismillahirrahmanirrahim. So let us start our module 11, and in this module we will be modeling and design the raft as per the ACI 31814. So the first step is to draw the mat area in the E tabs. So first let's just open the E tabs, and let's just for the just modeling we'll open that. We will go to the base. We will unlock the model, and for the thumb rule, uh, there's a thumb rule in order to take the initial thickness of the raft is the 4 times number of stories. For example, if you have 10 stories, then you have to multiply 10 with 4. So for the start, you take the thickness of the raft is 40 inches. So we will define a new section by going into the slab section, a new property. We will write as a raft 40. The slab FC prime for the raft will be 4000 psi, and the type is slab, and the modeling type will be shell thick. The shell thing will not incorporate the shear deformation, while the shell thick will incorporate the shear deformation in the raft, and it will tell you whether the thickness of the raft is sufficient for the punching or for the whether additional shear reinforcement is required in the raft or not. And this will we take as 40, and we will quickly draw the slab property. We will select raft 40, and we will drag it down from top to bottom. Let's just open the floors, right? So this is the raft. For the in case of the lift pits and the column pits, you can either add the openings in the raft by leaving opening, how you can draw the opening, and you can implement those reinforcement in the lift pit as well, that is required in the raft, the maximum, or you can draw the separate raft property. For example, the lift pit is 60 inches and the raft is 40, so you can do that, but there will be no significant effect in the overall reinforcement. So if you are in a hurry, or if you want to make it quick, or if you want to use the opening, or you want to use the different section, the results will be the same. So we will be using the same thickness in the raft, but in the detailing, you will drop the level of the raft in the lift area to make it as a lift pit, but the reinforcement will be same that you have used in the raft. So you have defined the draw the raft. Now you have to apply the loads. It will be acting as a parking for the this commercial building. You must apply the parking load, must be assigned shell load uniform, and you must assign live load of 60 psf, and the SDL of 50. That was 60, that will be SDL will be 50. So if you right click on it, And you can see on the load, the live load is applied on 60 and the SDL is 50. The next step would be that you run the analysis. There is nothing else you have to do. After the analysis, when analysis is completed, just like this, I have run the analysis, then you have to export the raft to the safe. Just we have exported the slabs story F2K file, select this time base, export all the loads, flow loads and the loads from the above, click OK, and you name it, for example, Raft 40, and save it. After that, you have to go to the save and import that F2K file, that is Raft 40, and in here you will select the design code from the preferences. For example, this is ACI 1314 and these are the strength reduction factors as per this code. The slab minimum thickness, the clear cover is 3 inches in case of the foundations, and preferred bar we want to use is number 6, and this is 2A slab. So click OK. The next step is that you would assign the soil property to the raft, right? So the first step was done, the second was also done. They import the reactions or the loads from the ETAB to SF2K file to the safe, or you directly uh, import or export the raft into the safe. The next step is to define the subgrade modulus, which will represent the soil, and it is defined as Ks is equal to Q ultimate divided by the allowable settlement, and the allowable bearing capacity QA is equal to Q ultimate divided by a factor of safety, and the Q ultimate will be equal to the Q allowable into factor of safety. So if you insert these values in this equation, the final equation will be 12 times SF into QA, right? So we will take the level bearing capacity of our building is 2 TSF, 2 ton per square foot. So we will multiply this 10 is 12 is from here, 12 into 3, 3 is the factor of safety, and 2 is the allowable Q allowable, which is the in tons. To convert it into pounds, you have to multiply with the 2204. So you will get the value in pound per cubic feet. So this is the value we got for the subgrade modulus is 158,688. So you have to define subgrade modulus, a new property. Click on the linear because you have used the linear analysis. This is you want to use it for the tension only for the compression only as a non-linear analysis, and this is for the elastoplastic. This is for the non-linear time history analysis, and for the pushover analysis, if you want to use that, you can use these options as well. So we are using the linear, so we'll define it as 158,688, and let me yes, and click OK. So this has been defined. You can name it, for example, as 2TSF. Now select your raft and go to assign support data, assign soil properties, and assign 2TSF. If you want to cross check whether the loads has been transferred from the ETAB to the safe or not, you can click on the grid. For example, this is the grid. If you right click on this point and click on the loads, you can see that the loads from the ETAB has been imported into the safe, right? So these are the different reactions from the earthquake, from the gravity loads that has been transferred into the safe. The next step is that you would be click on this and you run the analysis. right? So I'm not doing that because I've already run the analysis. When you run the analysis, so this type of shape will appear, and it is actually the displacement of the raft. So you can check the displacement of the raft for the different cases, for the dead load, for the live load, for the load combos, for load combo 1 and 2, right? So you can see that for combo 2, the maximum settlement is -1, which is 1 inch, right? And the unit is written in here, in inches. This is actually ultimate, but the settlement is normally checked with the service loads. So you can define your service combo by adding the live, dead, and SDL in it, and you have to select the service initial. This is actually just a cross check. This is not compulsory in the design. Display deform shape and click on the service. You can see that the settlement is 0.8 inches in minus because it is in downward direction. It means that the settlement is not greater than 1 inch because the equation we have used is the equation in the Bowles book by the suggested by the Merhoff, and it is says that the for the raft the maximum settlement is 1 inch, which is equal to 25 mm. So this settlement is less than 1 inch. So the equation we have used, the subgrade modulus we have assigned is perfectly okay. The next, you can check it out the soil pressures as well. You can check the soil pressure for the service. You can see this is the soil pressure, which is 3917, uh, which is 4. This is 445511, and you can check in turns. You can check uh, the units as per your requirement. Let us check, for example, this value. For example, this value 3843 pound per square foot. For example, 3868. The capacity of the raft is 2 times 2204, and it is 4408 pound per uh, square foot. You will be thinking that in some of the areas the pressure is higher than the capacity. This is because we haven't used the nonlinear analysis. When you use the nonlinear analysis, then it will be less than the value specified in the UTEC report. Because the software is not capable of going into the beyond the elastic limit, and the soil properties that has the plasticity index and all other properties, I'm not going into the very detail. So this is how you can check it out, the soil pressures as well, if you are interested. The next would be step number 4, which is assignment of the subgrade modulus and the thickness, which we have the I have told you the thumb rule. So the mate is also treated as a two-way slabs, and it is defined in the ACI section 13.3.4 that the design and detailing of the combined footings and mate footing shall be in accordance with this section and applicable provision of chapter number 8, which is the chapter of two-way slab. Right. So after assignment of the thickness, so you can run the analysis which we have done. The next would be checking the raft thickness for the punching demand, and for this the demand to capacity ratio should be less than 1, and if the demand to capacity ratio is greater than 1 then we have two options. If the ratio is less than 1, then it is okay, but if the ratio is greater than 1, So we have two options. You can increase the depth of the raft, and the second option is that you define the integral beam uh, in the raft. So in our case, we will go to the display and click on the show punching shear design. You can check the demand to capacity ratio for R is less than 1. If you right click on it, so it will show you a report that it has been defined for the combo 2, and this is the effective slab thickness used by the software. This is the cover, this is the concrete compressive strength, and these are the different other properties. And you can see the maximum design shear stress is this, and the shear capacity is this, right? So it we have to divide this value by this, so this ratio will we get, which is 0.67. So the ratio is less than 1, so our design is okay for the raft. But if this ratio, let us say it is greater than 1, so let us change this thickness. We will define the thickness for the raft as, for example, 30 inches. We go to the display punching shear, and now you can see that the ratio for some of the columns is greater than 1. If you right click on it, so you can see that the maximum shear stress is zero point 0.2 and the capacity of the concrete is 0.18, which is less than this. That's why the ratio is greater than 1. So we have two options. You can increase the thickness, or you can design the raft for the integral beam. So how you can do that? You have to select the raft. For example, if you have a restriction that you cannot increase the thickness of the raft, then the next option would be that you define the integral beam. So you have to select the raft, go to the design, and click on the punching check overrides. And in here it says reinforcement allowed no, make it rebar ties, and it is orthogonal perpendicular. The Fy we are using is 60, and the rebar area diameter we are using is 0.75, which is number 6 bar, and the spacing would be 4 inches. We'll click OK. Again we will run the analysis. Now this time the software will calculate or design the integral beam for you, whether whenever it is required, where the ratio is greater than 1, it will design the integral beam. You can see that the ratio over here is less than 1, so it is okay. But in here the ratio is greater than 1, so it has designed the integral beam for you, and it says 5 times 10 dash 3 by 4 at the rate 4 inches center to center. If you right click on it, it says that the punching reinforcement design, the rebar strength is 60, the bar diameter is 0.75 inch, which is number 6 bar. The number of rebar set is 5, and the number of single legs per set is 10, and the typical rebar spacing is 4 inches. What does it mean? The 5 set means, uh, let me show here. For example, this is the section of the beam. These are the bars. This is actually the beam. So this two bars is called as one set. This is second. This is third. This set is fourth set, and these two bars, one bottom bars and one top bars. This is called as one set, right? So you need five sets. So you have five bars top and bottom, and a number of single leg. I have drawn the leg. This is called a single leg, right? So you need 10, 10 bars per set, right? You need a number of single leg stirrups. You need stirrups per set is 10, right? And the spacing for those stirrup would be 4 inches center to center. So this is how you can design your integral beam if the thickness is not sufficient to take the load coming from the superstructure, then and you have no option to increase the thickness, then you can go to design your shear reinforcement integral beams for your raft. Again, we will undo this, and we will increase the thickness as R40. So the second step is the reinforcement in the mat foundation, and that would be same as to a slab. It means that the minimum reinforcement ratios and the maximum that we have used in the slab will be applicable to the raft. So the minimum reinforcement can be calculated as per the section table 8.6.11, and we have explained this. There is no need to explain it again. Just a second. So that would be again 0.0018 into 60,000 into 40 into 12 divided by 60,000. So the minimum reinforcement that you must provide is 0.864 inch square per foot, and the next is 0.66 inch square per foot. So from this, the minimum reinforcement you can calculate is, if you want to use, for example, number 8 bar, which is 0.7 divided by 0.6864 into 12, that you must use number 8 bar at the rate 10 inches center to center as minimum reinforcement. So this is the governing, and it is applicable for both the top reinforcement as well as for the bottom reinforcement. And we will write the safe results in here. So let us check it the punching again. So there is no issue in the punching. The NC in here means that not calculated, because you have a retaining wall in here. So when you have retaining wall and beam, so it will not calculate the punching, because no punching will occur when you have beam or retaining wall. So for the reinforcement, you must go to the display, click on the show slab design, and this is the same step that we have used in the slab design. Click on the minimum impose, uncheck it first, and click on apply, and you can see that the reinforcement is The contours you can see is under the columns only, but when you click on the impose minimum, the contours will be expanded, right? Let us make it 0 0, right? Now you can see that, and this is the bottom reinforcement, and the top reinforcement is this one. You can see that the minimum is 0.864 imposed by the E tab, which is equal to the minimum that we have calculated manually. So let us go to the design, and let us use first for the bottom number 8 at the rate 10 inches, which is the minimum reinforcement as per the code. And you can see that the majority of the reinforcement has been controls has been disappeared when you use number 8 at the rate 10 inch center. If you keep on decreasing the value or the spacing, so the contours will disappear one by one, right? So we will use number 8 at the rate 6 inches center for the bottom. So all the contours will disappear, but in under few columns, the reinforcement will be required, and we will increase the reinforcement, and we will provide two-layer reinforcement in these areas, right? So if you are providing number 8 at the rate 6 inches in one layer, so if you want to make it in two layer, so the spacing in here you can provide is 3 inches. That you are telling the software that you are using two layers, right? And it will calculate as per the reinforcement, because there is no option in the different layers. We have to do it manually. So number 8 at the rate 3 means that you are providing two layers of number 8 bars at the rate 6 inches center to center. If you click on apply, so these contours will disappear, right? So the first one is that you provide number 8 bar at the rate 6 inches center to center under all columns, and then you will provide number 8 bars at the rate 6 inches center to center under few columns, and in the drafting you will specify those columns when you provide final drawing to the client. This is the bottom bars. uh, Let me make it small. Top bars. So for the top bars, again, we will select the minimum reinforcement as per the code, and let me show the overall contours. This is the overall contours for the top in direction 1 and direction 2. So if I use number 8 bar at the rate 10 center as a minimum, will it be enough? So it says no. You must provide additional reinforcement in the second layer in these places. Only in these places, in this line, and in the direction 2 in this line. So let us make it 5. So again, some reinforcement you must provide. So we will use 8 number 8 is 8 inches, and then we will make it 4. So now you can see the contours has been disappeared, and these contours can be ignored, because the reinforcement that you need is 0.067, which is very less reinforcement. So we will provide number 8 bar at the rate 18 centimeters in overall draft, and in these four places, in the direction 1 and direction 2, in these two places, and in the direction 2, in the top and bottom, we will provide number 8 at the rate 8 inch center, which will be equal to number 8 at the rate 4 inch center in the software. So we will use number 8 at the rate 8 inches center to center all over, and then we will use number 8 at the rate 8 inches center to center in corners. So this is how you can design the raft, top and the bottom. The next check would be the maximum spacing. This is actually, yes, this is also very important, that what would be the length of the bars in the second layer. For example, for the bottom, you can calculate this from the coordinates by going onto the edge of these contours, and it says in x it is 79.45, and if you go on the other edge it says 87.7. So let us make it 79 minus 86, so it is 7. So you can use 10 feet bar in the x direction, and this is 78, and at that it is 86, which is equal to 8 feet. So you can use 10. So let us update this one. There is no, so this is number 8 at the rate 6, and number 8 at the rate 6, and the length would be 10 feet in x and y direction. And similarly for the top, it is number 8 at the rate 8 inches, and number 8 at the rate 8 inches. And it is would be variable. You can use the 20 feet length bar, you can use 15, or you can use 10 feet bar, and similarly that can be checked with the contours. For example, this is 8, and this the contour. For example, in here the length is, check it out, it is 4.11, and it is 13 points, which is equal to 10 feet. So you can use 10 feet in here, and this one you have to take the maximum. This one is 94, 95, and this is 20, so it means 20 plus, so you can use 25, 24 feet. So it is variable. The one was is for 25 feet long. You will incorporate these changes in your drafting. This one is 4, and this is 25, which is equal to 20 feet. So you can use 20 feet cut length as well. So that would be different cut length bars that you can use in the second layer. The next and the final step is to check the maximum spacing, and it is also checked for the slabs that we have done. It says that it can be greater of or lesser of 2h and 18 inches, and we have 40, and it comes out to be 80 inches, and the next is 18 inches. and we have provided the spacing of 8 inches and 6 inches, which is less than the maximum limit of the ACI code. So this was the whole story about the design of the raft and the safe. So if you have any question, you can ask.